ABCD is a rectangular garden plot. P is a garden water tap. Find the distance from the tap to corner C. Before I begin, I just want to share with you my source, Mathematics for the International Student, MYP3, by Pamela Vollmer and Company. Going back to the problem, in this particular problem, I would like to use Pythagorean Theorem to solve this. Okay. Now, in Pythagorean Theorem, it can handle only right triangles, but as you can see, there are no right triangles here. So what we do is we create right triangles by projecting lines perpendicular to the sides of the rectangular plot. And since we don't know the sides of this rectangular plot, then we must assign variables for them. For example, from A to this point, let's say this is small letter A. From this point to this point, let's say it's small letter B. If this is A, then this is also A, okay? The same. If this is C, then this is also C from this point to that point. And one more. This is small letter D from this point to this point, okay? So let's use Pythagorean theorem. I would like to take this first triangle here below with the hypotenuse 8. Okay, so Pythagorean theorem says the square of the hypotenuse, which is 8 squared, is equal to this side, square it, which is d squared, plus the square of this side, which is a squared. Another triangle, take this triangle here, and it has a hypotenuse of 7, so 7 squared equals c squared plus this is also a squared. Another triangle that I can see here is this triangle with the hypotenuse 5 meters. So that's 5 squared equals the height of that triangle is the same as the height of this side here, which is C. So that's C squared plus the other leg of that triangle is B. Okay, so we have here plus B squared. And finally, we have this triangle here with no hypotenuse because that's what we're looking for. So let's just say it's BC squared equals this side here is B, so we have here B squared plus the height is the same as the height of this triangle, D squared. Okay. We can reduce the number of variables by expressing some of them like in terms of the other variables. For example, let's go back to this equation, 8 squared equals d squared plus a squared. We can say, okay, we need b squared here. What is b squared? Maybe we can use this. B squared is equal to 5 squared, which is 25, minus c squared. Okay? And d squared, we can make this equation d squared equals 8 squared, which is 64, minus a squared. Okay? And let's plug them in here. B squared is 25 minus c squared plus d squared is 64 minus a squared. We still have two variables here, but look at this equation here. It's either we express this in terms of express this equation c squared as the subject or a squared as the subject. I'd choose a squared. That's the subject. So a squared is equal to 7 squared, which is 49, minus c squared. Either way, we'll end up with the same answer. So this is 25 minus c squared plus 64 minus a squared is 49 minus c squared. And let's simplify. Okay, I'll just move here. I'm running out of space there. So pc squared is equal to 25 minus c squared plus 64 minus 49 plus c squared. We can cancel this too because the same term, same coefficient, and opposite sign, so that equals 0. So what's left is 25 plus 64, which is 89, minus 49, and that's 40. So PC squared equals 40. Get the square root of both sides, so PC is 40, or what's that? Let me go get my calculator. That's 6.32 meters. So that's our final answer.